Hello. So now we're going to talk about polyatomic ions. The first two videos, the first video was about ionic compounds, and the second video was about covalent compounds. Now we need to talk about polyatomic ions because you can't really go any further in studying these chemistry concepts until you know your polyatomic ions. And it is very important I can't stress this enough because this will come back to haunt you if you don't. It's very important to memorize, memorize, memorize these polyatomic ions because you're going to need them in every chemistry class that you take, and a couple of biology classes you're going to need to know these. So they look daunting at first, but they're really not that intimidating. So let's go over some of them, and then I'm going to show you a really easy way to memorize these, to memorize the charges and the numbers of oxygens and everything on them. I'll show you a real easy way to memorize them. First, let's go over this name, polyatomic ions. Poly means many, and atomic just means atoms, and ions mean it has a charge. Just for the purposes of this, we can say ions mean they have a charge. So they would be like a -1 or a 1 minus or 2 plus or something like that. And back on the polyatomic or back on the ionic compounds video, I showed you a periodic table with all of the charges listed for the columns for group A. So if you want, you can go back and review that, but you'll even if you don't review that right now, I'll bring that back up and we can catch up on that um, as well in this video. But so ions mean these many atoms. So there's going to be more than one atom of something. So a lot of times that means there's going to, in this case, there's going to be more than one element in the compound. So like as you can see over here in the box, we have carbon and oxygen, and we have chlorine and oxygen, and we have nitrogen and oxygen, phosphorus and oxygen, and sulfur and oxygen. We're covering mostly, the ones that you need to know mostly are the oxyanions, polyatomic ions. So that means the ones that have oxygen in them. So this polyatomic ions, they're going to have more than one element in them because they're going to have oxygen with another element. So, and then they're going to have a charge of like a 1 negative or 2 positive and so on. So polyatomic ions are a group of elements that put together, they have a specific charge to it. Now let's go over some examples of polyatomic ions just to get you familiar with them, and then we'll go more deeper into how to write these polyatomic ions, what the rules are, and some easy tricks to remember them. So this first one is going to be carbonate. So CO3 with a -2 charge, and the -2 charge applies to the whole thing. So CO3 put together with this -2 charge for the whole thing. This is called carbonate. And ClO3 with a negative charge to it, this is called chlorate. So as you can see, this top one, this first one, the element that we're dealing with, besides oxygen, the element that we're dealing with is carbon. So when you put it together with the oxygen, with 3 atoms of oxygen, because here's the 3 down here in the subscript, when you put carbon together with the 3 atoms of oxygen, you can add on the ending 8 to carbon. So carbonate is going to mean carbon with 3 atoms of oxygen. And chlorate, the second one here, we're dealing with chlorine. And putting together with oxygen, with 3 atoms of oxygen, we're just going to cross off this ene, this last part of the chlorine, and we're going to change that to 8. So chlorate. Now likewise, we can look at the third one, and the main element that we're dealing with that's paired with the nitrogen, or that is paired with the oxygen, the main element we're dealing with is nitrogen. And so nitrogen paired with 3 atoms of oxygen, we can take off the ending of this word nitrogen and put 8. So you end up getting nitrate. And let's see, the next one is PO4 with a 3 negative charge to it. So the main one we're dealing with is the main element that we're dealing with that the oxygen is paired with is phosphorus. And since it's paired with oxygen, we're going to take off the last section of this word, the orus, and we're going to change this to phosphate. So phosphate means a phosphorus element that has 4 oxygens. There's the 4 oxygens bound to it. Now one more, we have SO4, and there's a -2 charge there. The main element that we're dealing with is sulfur, but it's paired with an oxygen, or it's paired with 4 oxygens. So we're going to just take off the last little bit of this word of sulfur here, and we're going to change this to sulfate. So carbonate, chlorate, nitrate, phosphate, and sulfate. That means these elements that are in the word are paired with oxygen, paired with a certain amount of oxygen. And as you can see over here in the box, these have different numbers of atoms of oxygen to them. So carbon has 3 atoms of oxygen to it to get carbonate. Chlorine has 3 atoms of oxygen with it to get chlorate. Nitrogen has 3 atoms of oxygen with it to get nitrate. But phosphorus has 4 atoms of oxygen to get phosphate. And sulfur has 4 atoms of oxygen to get sulfate. And don't worry about memorizing these numbers, because I'm going to show you an easy trick on how to memorize how many oxygens are with each element. Now let's go back and look again at this top one, the carbonate. Carbonate, and remember that ATE, that means that we're joining the carbon with 3 atoms of oxygen, and the whole thing has a -2 charge to it. That's carbonate. But what if you have a molecule that has 1 less oxygen than this 3? Because see, there's 3 atoms of oxygen in carbonate. But what if you were to have the same thing just like carbonate, but a CO2 with a 2 negative charge to it? That's going to be 1 less oxygen than the carbonate. So 1 less oxygen than the carbonate is going to be called carbonite. Ite. So ITE. So if it's carbonite, it's still joined to oxygen, but it's joined to less oxygen than it is in carbonate. Carbonate, it gets 3 atoms of oxygen. Carbonite, it only gets 2 atoms of oxygen. Carbonate, it gets 3 atoms of oxygen, and carbonite only gets 2 atoms of oxygen. So the rule is that 8 is kind of the standard. 8, when you have 8 at the end of the word, that's the standard polyatomic ion. But when there's one less oxygen atom, you're going to call that with an ite suffix instead of 8. So carbonite has one less oxygen atom than carbonate. Okay, let's try some more. Now we have chlorate, which is chlorine plus 3 atoms of oxygen, and it has a negative charge, and that's chlorate. Well, if you take away one of these oxygens, then you're going to end up with O2, and the negative charge stays the same. So chlorine and 2 oxygens, and the whole thing has a negative charge. That's going to be called chlorite. Now let's look at nitrate. NO3 with a negative charge. Nitrate has 3 oxygens to it. But if you were to take away one of those oxygens and keep the same charge, you would have NO2 minus with a negative charge. So that would be called nitrite. Now phosphate. Phosphate is P with 4 oxygens, and it has a negative 3 charge. So that's phosphate. But what happens if you were to take away one of those oxygens? You would end up with PO3 and a negative 3 charge. So that would be called phosphite. So see, it just all depends on where your 8 is at. It all depends on how many oxygens the element has in order to be called an 8 at the end of the word. In this case, phosphorus has 4 oxygens with it, and that's what makes it be called phosphate. So, as we said before, nitrogen only has 3 oxygens at the end of it, and that's nitrate. So it's not about if you have specifically 3 oxygens, it's an 8, or 4 oxygens, it's an 8. It depends on the element, is how many oxygens it needs to have that 8 suffix at the end of the name. And then, however many that is, if you take away 1 oxygen from that, you change it to an ite ending. So an NO2 would be nitrite. So let's do the last one. SO4 with a 2 negative charge. This is sulfate. Sulfate. So if you were to take away, it's got 4 oxygens to it. If you were to take that 1 oxygen away, and you would end up with 3 oxygens, you would end up with SO3 with a 2 negative charge, because see, the charges stay the same. so it's still 2 negative. So if you have an SO3 with a 2 negative charge, that's going to be, of course, sulfite. So all you have to do is memorize the polyatomic ions that end in 8, and then you can figure out by removing one of the oxygens when that polyatomic ion is going to be ending in ite instead of 8. Now let's take this further. Let's go back and look at carbonate again. Carbonate. Carbonate is CO3. It's got 3 oxygens and it has a -2 charge. Well, so we know that if we remove one of those oxygens, this is going to be called carbonite. But what if we remove another oxygen? What if we take these 2 oxygens in the carbonite and we remove one, and now we just have plain old CO with a -2 charge? We could put a 1 down here for 1 oxygen, but it's not really necessary because you don't really write the 1s. They're just implied if you have a 1. So let me erase that. So CO with a -2 charge. You're going to keep the term carbonite, but you're going to add the prefix hypo in front of it. Hypo, because hypo means below or less than. So if you have a carbonate, which is CO2, and you have less than 2 oxygens, you only have 1 oxygen, then that would be called hypocarbonite. But what if it's going the other way? What if we take the carbonate up here at the top, the CO3 oxygens, and we add another oxygen to that? So we end up with CO4. So we have 4 oxygens. Well, we keep that name carbonate, but we put the prefix in front of it, per. And in this case, per is going to mean 1 more oxygen than 8. So we have percarbonate has 1 more oxygen than 8. It has 4 oxygens instead of 3. Carbonate has 3 oxygens with the carbon. Carbonite has 2 oxygens with the carbon. And hypocarbonite would have just 1 oxygen with that carbon. So the pattern here is we're going to have the name of the element that the oxygen is paired with, and then we're either going to have 8 at the end of it, or we're going to have the name of the element the oxygen's paired with, and we're going to have the suffix "ite" at the end of it. And then if it's a super 8, if it has another oxygen on top of that, then we're going to have per, and then the element's name, and then 8. If we have very few oxygens, if we have one less oxygen than the ite form of the polyatomic ion, we're going to add the prefix hypo, and then you say the element's name, and then with the ite at the end. So that's the pattern for naming all of these. Let's try chlorate. ClO3 with a negative. That is chlorate. But if you add an oxygen to that, if you put another oxygen on top of that, that would be ClO4 with a negative charge. That would be perchlorate. Or let's go down. If we take away an oxygen from this chlorate and we make ClO2 with a negative charge, because remember these are ions, so they're always going to have a charge. So ClO2 would be chlorite. And what if we took away another oxygen from this? So we just have ClO with a negative charge. That would be hypochlorite. Now what about nitrate? We have NO3 with a negative charge, and that is nitrate. So if we take away one oxygen and we have NO2 with a negative charge, that's going to be called nitrite. But what if we add an oxygen to the nitrate? So it doesn't have NO3 anymore, it has NO4, and the charge stays the same. Then we would get pernitrate. And what if we take an oxygen away from the nitrite? Nitrite is NO2 with a negative charge. So what if we just have NO with a negative charge? That would be hyponitrite. So let's try the phosphorus one. Phosphate is PO4 with 3 negative charge. That's phosphate. But what if we add an oxygen to that? So we would have PO5 with 3 negative charge. That would be perphosphate. Or what if we took away an oxygen from that phosphate and we only had PO3 and a 3 negative charge? That would be phosphite. And what if we took away another oxygen from the phosphite? So we have PO2 with a 3 negative charge. That would be hypophosphite. Okay, now one more. And we'll change colors just so it's easier to see. So we have sulfate, which is SO4 with a 2 negative charge. Sulfate. And so if we had one less oxygen, SO3 with a 2 negative charge, that would be sulfite. If we took away another oxygen, so we only have SO2 with a 2 negative charge, that would be hyposulfite. Or what if we wanted to add an oxygen to that sulfate and make it SO5 and keep the 2 negative charge? That would be persulfate. Okay? So there's a pattern there, and so all you have to do is memorize the 8th version of these polyatomic ions, and then by adding or subtracting oxygens to it, you can figure out what other forms that these come in and what they're called. Now I bet you're thinking, but Suzanne, how am I going to memorize all of these and their numbers of oxygen atoms and make sure I'm calling it by the right name? Well, there's a really easy trick to it on the periodic table. And as I said before, the periodic table is awesome because it's like a cheat sheet that gives you clues to puzzles in chemistry. Chemistry is like a whole bunch of puzzles, and the periodic table is what's going to give you the clues for the puzzles so you can solve it. So this is an up-close section of the periodic table of nonmetals. So I just did the right third of the periodic table and I blew it up so we could see it. And as you can see, there's this bold staircase right here that separates the nonmetals from the metals. The metals would be over on the left side of this diagram. So here's this staircase, just so you know where you're at on the periodic table. Well, first of all, what we're going to do is we're going to cross off the stuff that we don't need in this little area. Now this entire column, this 8A, the one on the very right, this whole column, we do not need to worry about this because this column is called the noble gases. And the reason why they were called the noble gases was it was actually a joke among scientists because these elements do not combine with any other elements. And so the scientists were saying it kind of snarky. They were calling them the noble gases because they're too noble to hang out with anybody else. They're too snotty. So it's sort of making fun of, you know, rich, noble people that don't know how to hang out with normal people. So the noble gases, we do not need this at all for polyatomic ions. So I'm just going to scratch this out right here so we remember we're not dealing with these. Also, since all of our polyatomic ions that we're dealing with have oxygen in them, we don't actually have a polyatomic ion that is oxygen based. Oxygen is just what goes with all the rest of the elements. So we're going to cross out the word of up here. We're going to cross out the oxygen and the fluorine because the fluorine's not going to be in any of these polyatomic ions that you need to memorize anyway. So we're just going to cross out these two. Now what we're left with is right next to the oxygen, where we crossed out the oxygen, what's left is this little row of three, the B, C, and the N, the boron, the carbon, and the nitrogen. We're left with these three right here, and then underneath the F that we crossed out, we're left with these three right here, chlorine, bromine, and iodine. So we're left with these. And then in between these two boxes that I just made, there is the P and the S, the phosphorus and the sulfur. So these are the elements that we're really going to be working with when we're dealing with polyatomic ions, at least in the beginning for your chemistry fundamentals. Now, everything in the pink, both of these boxes that we outlined, here's the one B, C, and N, B, C, and N right here, and this other box of three underneath the F, the chlorine, bromine, and iodine. These hot pink boxes are all going to have three oxygens. So I'm going to put after here O3, O3, O3. And we're going to put O3 for the chlorine, O3 for the bromine, and O3 for the iodine. So all of these elements in both of these hot pink boxes, the one going vertically underneath the fluorine and the one going horizontally next to the oxygen, there's three of them in each box. These are all going to have three oxygens in their polyatomic ions. So that means bromine, or boron, I'm sorry, boron is going to have boron O3, and that's going to be called borate. Carbon is going to have 3 oxygens, and that's going to be called carbonate. Nitrogen is going to have 3 oxygens, and that's going to be called nitrate. And then let's look down here on this row. Chlorine is going to have 3 oxygens, and that's going to be chlorate. Bromine is going to have 3 oxygens, and that's going to be called bromate. And iodine is going to have 3 oxygens, and that's going to be called iodate. Now, the only ones different from this are when we highlighted the P and the S, the phosphorus and the sulfur right here, that bridges those 2 hot pink boxes together. So these are both going to have 4 oxygens in them instead of the 3. So let's write those out, okay? So we're going to have P for phosphorus and 4 oxygens, and that's going to be phosphate. And then we have sulfur. Sulfur is going to have 4 oxygens, and that's going to be called sulfate. So that's a really easy way to remember how many oxygens go with which elements to give them the "ate" suffix at the end of the word for these polyatomic ions. Now also there's something we have to do about the charges. And yes, there's an easy trick to remembering what the charges are on these polyatomic ions also. And the key to this is to knowing that this section of 3 that's right next to the oxygen up at the top, this is a special section of 3. And the way the charges work on these 3 is that you're going to have a 3 negative for the boron, a 2 negative for the carbon, and a 1 negative for the nitrogen. And all the other ones are going to have the same charge as they would if we were dealing with the atomic charges in each column. Remember how I showed you in the ionic compounds? This entire column, the 7A, is a 1 negative charge. This entire column, the 6A, is a 2 negative charge. And this entire column, the 5A, is a 3 negative charge. So that's going to apply to everything else on here. So if we just follow this column down, the phosphorus is going to have a 3 negative charge when it's paired with 4 oxygens. The sulfur is going to have a 2 negative charge when paired with 4 oxygens. And the chlorine, bromine, and iodine are all going to have just 1 negative charge in their polyatomic ions. So let's do this again so we got it. First, we're going to cross out the entire column 8 because that's the column 8, the noble gases in column 8 are not going to mix with anything and become polyatomic ions. That's just not going to happen. Also, we want to cross out oxygen and fluorine because they don't have their own polyatomic ions. Then right next to the oxygen, there are these three elements. And then right below the fluorine, there's another three elements. And so all the elements in both of these hot pink boxes get three oxygens for their polyatomic ion ending in 8. So I'm going to write O. Since we don't have any room, I'm going to put the O around the B. O3, 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 O3. Now the only other box we have to worry about is this box that bridges the gap between the two hot pink boxes. So that would be the phosphorus and the sulfur. And these two elements, this in the purple box, they get 4 oxygens. So PO4 is phosphate and SO4 is sulfate. Now as far as the charges, everything in this column gets a -1 charge. This column gets a -2 charge. And this column gets a -3 charge, except for this special box up here, the special box of 3 up here next to the oxygen. These start over. These have a -3 for boron, a -2 for carbon, and a -1 for nitrogen. So let's try to write these. Let's try to write some of these out. And these are all in the 8 suffix for polyatomic ions. So what if we need borate? Well, borate, that's boron. Let's see, borate. So the root word of that would be boron, which would be this B right here. So boron is B. And then boron is one of those elements that gets 3 oxygens to it because it was in that hot pink box. And then boron is that special box that is going to be a -3. So this is going to have a 3 negative charge to it, and that is borate. So let's talk about carbonate. Carbon is what we're going to be working with, and that's right here. So carbon is in one of the boxes that gets 3 oxygens with it. And then it's in one of these special boxes that gets a -2 charge for the entire polyatomic ion. So CO3 with a -2 charge is going to be carbonate. Now the next one over, nitrate, is going to be the letter N, and then it's also in that box that gets 3 oxygens, and the nitrate was going to get 1 negative charge to it. So that could actually be written like that. So that would be nitrate. So this borate, what if we took away one of the oxygens from the borate? See, we have borate is right here, and we took away 1 oxygen. So now it's BO2. Now you keep the same charge, the same number charge, which is 3 negative. So you have BO2 3 negative, and that would be called borite because there's 1 less oxygen. Now what about this box in the middle with the phosphorus and the sulfur in it? Well, let's try one of those. Phosphate is what we want. So that's phosphorus, which is the letter P. And P is in that purple box where it gets 4 oxygens. And this is in column 5A, which gets a -3 charge to it. So we're going to have a 3 negative charge to it. That will be phosphate. If you want phosphite, then just take away one of the oxygens and leave the charge number the same, and that would be phosphite. Sulfur is the same way. You have sulfate is an SO4, and sulfur is in column 6A, which is a -2 charge. So we're just going to have that -2 charge be on there, and that is sulfate. Now we need to look at one more rule on top of the other rules for polyatomic ions. So first, let's doctor our periodic table here so we remember what we're doing. We don't need column 8A because they're noble gases. They're too snobby to hang out with anybody else. We don't need oxygen or fluorine because those don't have their own polyatomic ions. But what we do need is this section of 3 right next to the oxygen, which has a charge of 3, 2, and 1. And we need this section of 3 beneath the fluorine, which all has a charge of -1 for that entire column. And then we have the bridge, the 2 elements that bridge these boxes together, the phosphorus and the sulfur. And the phosphorus and the sulfur go by the regular column charges, so that's going to be a 2 negative and a 3 negative. And remember, the red and the hot pink box gets 3 oxygens, 3, 3, 3, and this gets 3 oxygens. And the purple box is going to get 4 oxygens with the element in order to make a polyatomic ion ending in 8. This is all for the ones ending in 8. So I'm going to focus on the purple box right now, the phosphorus and the sulfur. Let's go to the phosphorus first. Let's go to phosphate. Phosphate would be P with 4 oxygens, and it has a -3 charge to it. That's phosphate. And here's the thing about the charges. Whether you have phosphate, phosphite, because you took away an oxygen, or whatever, these charges are still going to stay the same. And so no matter how many oxygens you have with this phosphorus, the charge is still going to stay -3. Here is when the charge changes. When you have, let's say we have phosphate, PO4, and that's a 3 charge, but then we add a hydrogen to the beginning of it. So we want hydrogen phosphate. Hydrogens have their own positive, one positive charge to it. So when you add this positive charged hydrogen to the phosphate, that takes away one of these negative charges. So you're going to end up with a 2 negative charge if you have hydrogen phosphate. So what if you add 2 hydrogens to phosphate? Well, if you have 2 hydrogens, then that means you're going to have 2 positive charges. And here's your phosphate. So the 2 positive charges are going to come over and take away from that -3, leaving you with just one negative charge. And that would be dihydrogen phosphate, because there's 2 hydrogens. So dihydrogen phosphate. Now the same thing goes for phosphite. Remember, phosphite is when we've taken an oxygen away, so we have PO3. So PO3 with a -3 charge is phosphite. So we have PO3 with a -3. If we add a hydrogen to this, for hydrogen phosphite, that hydrogen has a positive charge to it. So it goes over and it takes away one of the negative charges in the phosphite. So you will end up with hydrogen phosphite with a -2 charge. So that would be hydrogen phosphite. So what if there are 2 hydrogens with this phosphite? So we have hydrogen 2, and here's phosphite with a -3 charge. These 2 hydrogens are going to have a +2 charge. It's going to go over and cancel this out and give you just one negative charge. So H2PO3 with just a negative charge is going to be called dihydrogen phosphite, because the ite stays the same because it still only has 3 oxygens to it. So let's do one more. Let's do sulfate. So sulfate is SO4 with a -2 charge. But what if we add a hydrogen to that sulfate? So now we have a hydrogen with a positive charge and the sulfate with a 2 negative charge. Well, that hydrogen, that positive hydrogen charge, is going to go over and take away one of these negative charges. So you will end up with HSO4 and just with one negative charge to it. And that would be called hydrogen sulfate. Or what if you want to take an oxygen away? Now, what if you want to take one of the oxygens away and end up making that an HSO3? Well, then that would be called hydrogen sulfite. because it has one less oxygen than the sulfate. Oh, and this has a negative charge to it. So I hope that makes sense and that helps you to try to memorize your polyatomic ions and figure them out. If you need any help or need anything explained, please leave a message in the comments below and don't forget to like and subscribe.